Hey guys, I'm making this video series for VTU M3 students, and if you're 21 scheme students, then you will be writing the exam for the first time, 21 and 31, and for 18 scheme students who have M3 backlog. And if you like these videos, please subscribe to our channel and share these videos with your classmates and friends so that it will help them also. Okay, so the question is, find the Laplace transform of cos hyperbolic t into sine cube 2t. So we have product of two t functions, one is cos hyperbolic t, another one is sine cube 2t, and then we have to find the Laplace transform. Okay, individually I might know what is the Laplace transform of each of these function. So Laplace transform of sine at is a over s square plus a square. Okay, and then Laplace transform of cos hyperbolic at is equals to s over s square minus a square. Okay, but if you have product of these here and if you take product of these two, that is not the same case. Okay, that is not how it works. So Laplace transform is it is not linear. The product of t functions is not same as product of s functions. And also you have sine at. The quotient of t can be anything and this formula still works, but the power of sine must be 1. So we have formula for sine power 1t, and if you take just cube of these two, you will not get the Laplace transform of sine cube 2t. Okay, it doesn't work like that also. So first we have to reduce the power of sine from 3 to 1, and then also simplify this. Okay, and in a way so that we can use this property. This property that we have learned, right? Property is e power at into f of t. So if you have any function multiplied with e power at, then the taking Laplace transform of this is same as taking Laplace transform of f of t, which is f of s, right? And then replacing s with s minus a, where a is the coefficient of t in the e power at. So we have to use this form property. But there are no e power at terms here, right? So, but we have cos hyperbolic t. Okay, so from trigonometry we know cos hyperbolic theta is same as e power theta plus e power minus theta by 2. Okay, so a cos hyperbolic term, any cos and sine term can be written as exponential in the sum of exponential terms. Okay, so you have to use this here. So if you use that, f of t will be cos hyperbolic theta. In place of theta, I have t here, so it will be e power t plus e power minus t by 2 into sine cube 2t. So what I said was about powers, we have to have power 1 only. So how can you reduce power 3 to power 1? If it is square, we will use God formula. Sine square theta is 1 minus cos 2 theta by 2. If it is cube, we have one more trigonometric formula, right? So sine cube theta is 3 sine theta minus sine 3 theta. The coefficient of theta changes to 3 theta, okay, but the power of both of these terms is just 1. Sine power 1 theta, sine power 1 3 theta. So from cube I convert them to power 1. Now I can apply this formula to here, okay, where a is 1 in this case and a is 3 in this case. Okay, so multiplying this here, in place of theta I have 2t, right? So it will be 3 sine 2t minus sine 3 theta, means sine 3 into 2t, which is 60. Okay, so this is what I get. So before applying this property, I will simplify this one more step. So I'll get f of t is equals to this 1 by 2, I will take outside, and then first term into this term, so that is e power t into 3 sine 2t minus sine 60 e power 1t. Let me write it like this. Then this plus second term e power minus 1t into 3 sine 2t minus sine 60. Okay, close bracket. Okay, this 1 by 2 is common for all of these terms. Now we have e power at into f of t, e power minus 1t into f of t. Now we can use formula. First we need to find f of s, which is Laplace transform of f of t, and f of t here is this, right? So it will be 1 by 2, 3 as it is. Laplace transform of sine 2t is, Laplace transform of sine at is a by s square plus a square. This will be 2 by s square plus 2 square minus sine 60 is 6 by s square plus 6 square. In place of a I have 6, right? So that's how it works. Then plus, before writing plus, so this is the Laplace transform of f of t. Now in this we have to replace s with s minus whatever the quotient of t here we have. So that will be 1 here. Okay, and then plus again the term is same as here, so the same Laplace transform will be here also. That will be 3 into 2 is 6 by s square plus 2 square minus 6 by s square plus 6 square, and then replace s with s minus, the quotient of t here is minus 1, it is plus 1, here it is minus 1. So replace it with s minus minus 1, which will be s plus 1. Replace s with s plus 1. That will be the Laplace transform. So that is taking Laplace transform, that we got here it right. So Laplace transform f of t is f of s. So my f of s will be, in all of the terms I have 6 in the numerator, so I'll take the factor out 6 outside, so that will be 6 by 2, and in the inside I will have 1 by, in place of s, s minus 1, so that is s minus 1 square plus 4 minus 1 by s minus 1 square plus 36 plus 1 by s plus 1 square plus 4 plus into minus 1 by s plus 1 square plus 36. Okay, so this is the current step in the final Laplace transform. So 6 by 2 will be 3. I think you can leave here, but there is still, you can still simplify this further. Okay, how can you do that? First, you have to group these two. Okay, and then you have to group, like in the previous question that we have did, taking LCM directly doesn't give us anything. So before taking LCM, we have to simplify these two such that you will get a plus b into a minus b in the denominator. So that LCM will be a square minus b square, right? So how do you do that? So simply, I'll write it. So s minus 1 whole square is s square minus 2s plus 1 square, that is 1. So plus 1 plus 1 plus 4 as it is. So I can write this as s square plus 5 minus 2s. Okay, and here same, s square plus 2s plus 1 plus 4. I can write it as s square plus 5 plus 2s. So if you compare these two, you have a minus b into a plus b. So if you want to add these two, you can simply take LCM as the product, it will be a square minus b square. Similarly for this also, it will be s square minus 2s plus 1 plus 36. So that will be s square plus 37 minus 2s, and here it will be s square plus 2s plus 1 plus 36. It will be s square plus 37 plus 2s. Okay, so we add these two, 1 and third term first. So I'll get as 3 by 6 by 2 is 3. How will you add? Cross multiplication and then multiply the denominator. So total denominator will be a minus b into a plus b, which will be a square minus b square, and in the numerator this into this. So that will be s square plus 5 plus 2s plus this into this. So that will be s square plus 5 minus 2s. Okay, and then this minus I'll take as common, and the denominator I'll have this into this. So that will be a plus b into a minus b. So that will be a square minus b square, and the numerator this into this, this into this. So that will be this into this will be s square plus 37 plus 2s plus, I have already taken minus outside, so it will be plus now. So plus s square plus 37 minus 2s. Okay, so this 3 is multiplied to everything. Okay, so let me continue it here. So my f of s will be plus 2s minus 2s get cancels. So s square plus s square is 2s square plus 5 is plus 10. And the denominator, you can just keep it here. You can simplify it also, or you can just keep it also. I think what you will get if you simplify, s square plus 10s square plus 25 minus 4s square, which will be, I think it will get s power 4 plus 6s square plus 25, right? And again this minus, again plus 2s and minus 2s get cancels, plus 2s and minus 2s get cancels. So we will get s square plus s square is 2s square plus 37 is plus 74. 74 divided by, you will get s power 4, 74 minus 4 will be 70 plus 70 s square plus 37 square. Plus 37 square is, I'll just write it as 37 square. You can use your calculator and find it out. And this everything is multiplied to this 3. Okay, so you can leave it here. You don't need to again cross multiply and solve anything here. That is the till here. If you get right, that's all. Okay, till here. Okay, after replacing s with s minus 1 and s with s plus 1, whatever you get here, that is actually the answer. And then everything else is again extra. Okay, just simplifications. Okay, and then you can just stop here. You can continue also. So this is how you find the Laplace transform of cos hyperbolic t into sine cube 2t. Power also you have to reduce to 1, and cos also you have to convert to exponential term, and then use the property e power a t into f of t. Okay, so that is the end of this video. So the simplest way to improve your CGPA is by studying the previous year question papers, and this works for all branches, any subjects, and for engineering math subjects, especially for M3, we have prepared an e-book, solutions to previous year question papers and model papers, that I think will help you enormously. Okay, I will leave the link to the ebook in the description. Please go check out our ebook. And if you are somebody who don't want to take any chances and prepare thoroughly for the examination, and if you are somebody who needs help understanding the solutions that are written in the book, you can check out our course, which is amazing and self-paced and very affordable. And I will leave the link to the course in the description. Please go check out our course.